Okay, function notation. In the intro, it kept showing you this outline for what function notation looks like. That would probably be a good thing to put in our notebook because that outline kind of tells you where to look for different things if you see something that's written in that notation. And the outline looked like this. It was some sort of letter sitting out in front that they kept telling you was the name of the function. Functions are usually named with letters. It does not matter what letter you use. You could use A, B, C, D, whatever you want. F is popular because F is short for function. But you don't have to use an F. You can call your function anything you want. The reason why we give functions names is so that we have multiple different ones. Let's say we have like 2 or 3 different things we're working with. We can give each of them a different name, and that lets us tell them apart. So that's one advantage of function notation. Question?
Can we turn off some of the lights so
If you turn off the lights, it's actually going to dim this and make it harder to see because there's not a light shining down on here. That makes sense? It'll make this darker too. So functions have names. You can give them different names. That's one reason why we might use function notation is because it gives us a way to give different names to things when we have more than one thing we're trying to keep track of. So if you're wondering, function notation, great. Why do I need this? One reason is it's great for keeping track of multiple things at once with different names. After the name came these parentheses, and they told you in the intro that that's where the input lives. So whatever you're dropping in that you want your function to use. And then it's going to shoot out an output. So a function's a lot like a machine. You give it something, you feed it something, you put it in, it does something to it, and then it shoots out an answer. You can give it something else. It'll do that same thing to whatever you give it. It'll shoot out the answer. So whatever you put in, it's going to do whatever it's designed to do, and it's going to shoot out the answer based off of what you give it. So it's kind of a different way of organizing an equation with an input and an output. That output you would need to be given. So we're going to make one up just to kind of check in with this and make sure you understand it. Let's say we have a function and our function is going to multiply by 4. Then subtract 1. So this information would have to come from somewhere. Maybe you're looking at a pattern and this is what the pattern does. Or maybe you're looking at an application problem and you've come up with an equation for that application situation and this is what's going on in the situation. So this information doesn't just magically appear. It comes from whatever situation you're working with. So in this particular situation, what's happening with the pattern is that things are getting multiplied by 4 and then subtracting 1. So 1 smaller than quadruple. So that's where that comes from. The thing with the function though, because we're in math we usually use symbols to represent things and not words, right? So let's say you're looking at a pattern, kind of like our checkerboard pattern or another pattern. You notice this happening, this multiply by 4 and then subtract 1 pattern. Can I turn this into an expression with numbers? What would that look like in numbers? Multiply something by 4 and then subtract 1. Laura?
In parentheses, you could do 6 times 4, and then outside of you could subtract 1.
Okay. And so if I don't know what my thing is, because I can put anything I want in for the input. I could put a 1, a 2, a 20, 5,043,000. What can I use to represent that generic input? Yeah. So I'm going to be generic to show that I can throw anything I want into my function. So if I wanted to clean this up and express it with variables as an expression, this same thing would be 4x. That's where I take something, whatever I want, multiply it by 4, and then subtract 1 from it, right? So usually you'll see what's happening with your function written in numbers instead. So I can take this and I can put this into our notation so that I have something that looks like a function. And remember how I said you can call your function anything you want? I'm going to call this function R since we're in red neighborhood. Whatever you feel like. So if I wanted to take this and put it into our outline, I'm going to fill the name I've chosen into the name slot. So I've decided I'm calling this function R. And what I'm going to say is that whatever I put in, it's going to give me out 4 times that amount minus 1. So usually a function and function notation will be written like this. You'll be given some sort of statement that looks like this, that tells you the name of the function and what the function does to your input. So I'm going to label that. So here's the name. And then this part is what's happening to my input. So what's happening, or what happens to the input. From there, I could fill in whatever input I feel like. So let's say I want to put a 3 into my function. So the way that I would show filling in an input is right here in this input slot, right? So I could say, let's put a 3 into the function. It would look like this. Take function R and fill a 3 into it. In the video intro that you guys watched, they were saying this R of 3. That's how you would say that if you were going to talk about it out loud. The name and then of and then whatever input you're filling in. So R of 3. So this is what we're filling into our function. So we said our function multiplies by 4 and then subtracts 1, right? And that's why I said a function is kind of like a machine. You drop something into it, does a bunch of stuff, spits out the answer. So we're dropping in a 3. Now it's going to do some things to that 3, right? So it's going to take the 3 and it's going to multiply it by 4 and then subtract 1. What is 4 times 3 minus 1?
11.
Right, 11. So function R, if I fill in a 3, it's going to put out an 11. So I could say that R of 3 gives me 11. And it's because of this middle part that tells you what's happening to the 3.